Yeah, good morning to all of you. In previous lecture, I have discussed the concept of electric field due to a uniformly charged solid sphere. Now, in this case, I will discuss what is the profile of electric field or expression of electric field for a spherical cell of a spherical or uniformly charged spherical cell. So, in this case, so what is a spherical cell? So a spherical cell is a hollow sphere of a small thickness. So this is, so let me draw the spherical cell. So this is the schematic of spherical cell. So spherical cell is a hollow sphere of small thickness, and we want to find out the electric field using Gauss law. So Gauss law. So using Gauss law we can find out the, so again in earlier case we have a uniformly charged solid sphere. We have, in this case we have simply a spherical cell which is a hollow sphere of small thickness. So we can find out the electric field at any point P which is outside, at any external point, or at any internal point. So in this case we have also two different situations. So let us see. So what is electric field? E outside. So what we have, given that in this case, given that charge is, so Q, the spherical cell of a small thickness having charge Q, radius R, and we want to find out E outside and E inside. This is simply the problem. So using Gauss law we can find out the electric field through this spherical cell. So first we will evaluate the outside electric field profile due to a outside. So using Gauss law, so what is Gauss law? Gauss law simply states that flux through any surface, that is closed integral ds, E dot ds is equal to charge enclosed divided by free space. So in this case we want to find out electric field at any point P. So again this is again 4 to 5 step process. Recognize the geometry, draw the corresponding Gaussian surface which is imaginary surface, and find out the charge enclosed, then evaluate E dot ds, and then equate left hand side to right hand side and rearrange in order to find out the profile of electric field. So this is the steps through which we can apply the Gauss law. So first, we want to find out outside profile. So this is the point, and draw the corresponding, again this is a spherical cell. So Gaussian sphere, Gaussian surfaces, Gaussian sphere, this is GS, Gaussian sphere, and this point is P, and the distance of this point to this is R. So we have only this spherical cell. We can draw these steps. We can draw these Gaussian sphere in order to find out the electric field at outside this spherical cell. So again, what is charge enclosed? If Q charge is here, this is given. The spherical cell having a small thickness, charge q, radius r. This is already given in the problem or example. So charge enclosed in this case is, again, what is charge enclosed in this surface? Simply q. Charge enclosed is simply q. And what is E dot ds? Again E into E dot ds. If you take E is radially outward and ds is normal to the surface, so direction of E and ds are E ds are parallel. So angle between them is 0. So E dot ds is simply E ds cos theta. So cos theta is 0, which means cos 0 is 1. So E ds is simply E ds. If r is the radius, so this is the area of sphere. Surface of E ds is total integral. So total area of this sphere is 4. If radius is smaller, so again E into 4 pi r square. So this is the left hand side. This is LHS and this is RHS. So again E into, now putting the value of E dot ds, which is simply 4 pi r square, and q enclosed is q. So what is electric field? Is simply 1 upon 4 pi epsilon 0 q by r square r. Again it behaves as a point charge. Electric field due to a spherical cell at any point P. So E outside, let me write this is outside. So this is the outside profile, which is again a point charge profile. So electric field due to a spherical cell at any point P, which is outside this spherical cell, is 1 upon 4 pi epsilon 0 q by r square. Next we have a case, what is the electric field profile inside this spherical cell? So inside is, again applying Gauss law, we can apply Gauss law, which is E dot ds, which is charge enclosed by epsilon 0. So this is the spherical cell. In earlier case we have find the electric field profile due to this spherical cell at any point P, which is outside. In this case we have to find out the electric field. Is per charge is q, and now in this case we have to find out electric field due to this spherical cell inside at any point, inside this spherical cell. So this is inside point, we can take any point whose distance is, and draw imaginary surface, that is again Gaussian sphere. This is, in earlier case Gaussian sphere is outside, because we want to find out the electric field outside the spherical cell. In this case we have to find out, or we will find out electric field due to this spherical cell at any internal point, let's say this point is again P or R, let me write, this is M, at any point M. So we can find out E dot ds. We have a profile of E dot ds because the radius of this is simply r. So what is E dot ds? E dot ds in this case is also E into E ds cos theta. So E into 4 pi r square, because again ds is normal, area vector is normal to the surface, electric field is radially outward. So direction of E and ds are in same direction. So theta is 0 and ds is 4 pi r square. ds is integral ds is 4 pi r square. But what about charge enclosed? So we have this left hand side. This is simply E into 4 pi r square in this case. And what is charge enclosed in this case? What is charge enclosed? Because this is a spherical cell, charge resides on the surface. There is no, if you draw any Gaussian surface inside this spherical cell and will try to find out the profile of charge enclosed. So in this case charge enclosed is 0 because this is a spherical cell. Charge resides only on the surface. So charge enclosed is 0. So that's why 0 upon epsilon 0. So electric field is 0. Because of this, because of the charge enclosed in this case, in second case are spherical cell at any are in this figure. Let me, this is figure A and this is figure B. So in figure A, charge enclosed in this surface, in this dotted surface is Q, but charge enclosed in this dotted surface is, because charge resides here, charge resides on the surface of this spherical cell. And if you draw the any surface which is inside this spherical surface, and we'll try to find out the charge enclosed. So in this case charge enclosed is simply 0. There is no charge inside the spherical cell. That is why electric field due to a charged spherical cell is 0. So inside is 0. So electric field inside is 0. And you can plot this also. We can plot this profile also. So for inside is 0. If we have a spherical cell, let me again, variation of E. Yeah, let me just so we have two different situations. This is a spherical cell. This is figure A and this is figure B. In this case, electric field outside, which is 1 upon 4 pi epsilon 0 Q by R square R cap, and E inside is simply 0. So corresponding to these two different figures, we have two different profile of electric field. In this case, electric field is simply, we have such a point charge. In this case, electric field at, if you want to find out electric field at any point, this point is 0 because electric field is, and in this case E is simply proportional to 1 by R square, and in this case E is equal to 0. So we can plot variation of E and R for case of uniformly charged spherical cell. So this is uniformly charged spherical cell, and this is distance R, and this is the variation of E. Let me take E is along y axis and R is along x axis. So what is the profile of variation of electric field due to this uniformly charged spherical cell of small thickness? So inside, if you take the profile, this is, so inside electric field is 0. So if you take, if you want to find out electric field from center to this point, this point, this point, this point, this point, this point, up to the thickness of spherical cell, what we have? We have E equal to 0. We have E equal to 0. If you, and what about outside? Outside we have this profile. Electric field followed this profile. Inside it is 0 because charge resides only on the surface. So there is no charge enclosed inside the spherical cell. Therefore electric field due to a charged spherical cell inside at any point is 0. But outside it behaves as a point charge and it follows the profile E proportional to R square. So up to here, this is 0. And outside the sphere, this is E proportional to 1 by r square, which is r greater than r. If r is the radius of this spherical cell, if r is the radius of this spherical cell, so electric field, you can write the profile E equal to 0 for r less than r, or r equal to r, and E is proportional to 1 by r for r greater than r. So this is another very important objective type question, that what is the profile of electric field, or what is the variation of electric field with distance for the case of uniformly charged spherical cell of radius r and thickness is very small. So electric field E equal to 0 for r less than r or up to the r, and electric field is directly proportional to 1 by r square for r greater than r. R greater than r, it follow the profile of this one, and r less than r, it is 0. And in earlier case we have different profile. For the case if it is simply uniformly charged solid sphere, so we have different profile. So let me write this one also. If you have a uniformly charged, so this is a spherical cell. This is simply a sphere. This is simply a sphere. Of radius r and charge q. And what is the profile? This is again distance, and this is electric field. So what is the profile? What is the profile in this case? In this case, electric field is simply E outside is 1 by r square, and E inside is, this is A for sphere, and this is B for spherical cell. So we have to, let us analyze the graphical representation of these two different cases. What we have a uniformly charged solid sphere, and we have a uniformly charged spherical cell. And let us compare the profile of electric field in two different situations. So for case A, for a sphere, uniformly charged solid sphere of radius r and charge q. In this case, we have already find out the electric field profile, which is simply, I am just talking about the proportionality. So in this case, for uniformly charged solid sphere, electric field inside at any point behaves as a linearly behave. So this is this one, and outside it behaves like that. So in this case, this is E proportional to 1 by r square, which is outside, and this is inside, which is proportional to r. So this is the basic difference between uniformly charged solid sphere and we can write the profile. So E equal to rho r by 3 epsilon not r cap when r is less than r, and E equal to r. Let me write just proportionality. E proportional to r for r less than r, and E is 1 by r square, r greater than r. So this is the graphical representation. Let me rewrite. 1 by r square, r less than r, and r greater than r. So E inside for the case of sphere. This is sphere and this is spherical cell of small thickness. So this is the graphical representation of electric field or variation of electric field due to with distance for the case of uniformly charged solid sphere and for the case of spherical cell of small thickness. So in both cases we have different profile. But the electric field profile, what is common? What is common in both cases? The outside profile is same. In this case, E electric field outside is governed by 1 by r square for the case of sphere, and for the case of spherical cell we have electric field is also 1 by r. For r greater than r, electric field, this is inside and this is outside. So E is outside. For r greater than r, we have a same profile of electric field. But for r less than r, electric field inside the uniformly charged solid sphere is directly proportional to r, but it is 0. So it's all about the electric field and their comparison. We can compare the result. We can compare the result, and this we can say that this is the simply graphical representation of variation of electric field with distance profile. And let me write. This is the half part of the sphere. This is the half part of the sphere. If you draw, so you will get the complete profile, because this is the mirror image. This side is just the mirror image of this side. So we can, if this is the center, so if this is again E is outside is proportional to 1 by r square. We can draw, simply we can draw here. So electric field is this one, and so this is E proportional to r, E in, and this is E out, which is proportional to 1 by r square. So this is the complete representation of variation of electric field for uniformly charged solid sphere and spherical cell. So both side we can represent the both side variation of electric field. So left hand side just the mirror image of right hand side. Okay, thank you.